Alright, so partial fractions, like all other fractions, can be improper. And when are they improper? So, whenever the maximum power of the numerator is greater than or equals to the maximum power of the denominator. It is an indication that the fraction in consideration is improper. Thus, we'll have to apply long division. It's similar to conversion to mixed numbers, you can say, but yeah. So, long division is similar to how we learned to divide in polynomials, and so this is what we have. So, I should have a 1 in the quotient, and thus I have x squared plus 5x minus 6. I subtract the whole thing, and the remainder turns out to be, yeah, 13. And we move. So I can rewrite this whole fraction as 1, that is the quotient, plus 13 over x squared plus 5x. Notice how this is similar and how this is different from writing mixed numbers. So 13 over x squared plus 5x minus 6 is my partial fraction part. And I solve this like I solve partial fractions every time. I'll start by factorizing the denominator, and mhm, so x squared plus 5x minus 6. I can break the middle term, so I write this as x squared plus 6x minus x minus 6. And I'll take x common, so I'll be left with x plus 6, and I'll take minus 1 common, and I'll be left with x plus 6. And the factors turn out to be these: x minus 1 and x plus 6. So I can rewrite this as 1 plus 13 over x minus 1 and x plus 13 x minus over x minus 1 x plus 6 is a partial fraction to be dealt with. We do not need to deal with 1 for now. I'll write 13 over x minus 1 into x plus 6. I'll follow the first step as always: a over x minus 1 and b over x plus 6. I'll cross multiply and cancel off the denominators in one step, and this is what I have. Now apply the cover up method as always. So when x is equals to minus 6, so a like cancels off, or this thing just becomes 0. So I'll be left with 13 is equals to, this became 0, and I have minus 7b, and b turns out to be minus 13 over 7. Now when x is equals to 1, so it becomes 0b, that is, it cancels off this one. So I have 13 is equals to 7a, and a turns out to be 13 over 7. So I can rewrite 13 over x minus 1 x plus 6 as 13 7 x minus 1 minus 13 over 7, that is b into x plus 6. But this is not my answer. This whole thing is not. I must not forget the 1 that we had. So 1 plus the whole thing is my answer. We must not forget the 1. So moving on to our second example: 3x squared plus 2x minus 7 over x minus 1 x plus 2. The denominator is factorized, but we do know that it will turn out to be a quadratic. Thus, the maximum power of the numerator is equals to the maximum power in the denominator. So it is an indication that that improper fractions is being considered. Thus, I must apply long division. So first of all, let's expand the denominator. In doing so, rewrite the fraction. And we have x square. So, yeah, 2x minus x. So, I'll have plus x minus 2. Make a column for long division. This is similar to polynomial long division. And 3x square plus 2x minus. So now I should have a 3 in the quotient. Yeah. So I have a plus 3x and also a minus. Subtract the whole thing. 3x squares cancel out, and you will be left with minus x and minus 1. Yeah. So I can rewrite this as 3. Yeah, I can rewrite this thing as 3 plus, wait a second, 3 plus and minus x minus 1 over x square plus x minus 2. So we need not consider the 3 here, but we need to consider the partial fraction, and x square plus x minus 2 can be rewritten in the factorized form. That's why I made the arrow. So this is what we have, and we can use partial fractions to solve this thing. So we first of all rewrite the thing, and we have a over x minus 1 plus b over x plus 2. So I'll cross multiply and cancel off the denominators from both sides at the same time, and this is what I am left with. So now I'll use the cover up method, the easier of the two methods. When x is equals to, let's take this to be 1, so I'll have 0b, and a turns out to be minus 3, no, minus 2 over 3. Yeah. So when x is equal to minus 2, so I'll have 0 and a like cancels off, and b turns out to be minus 1 over 2, minus 1. So now I can rewrite the part. I can rewrite the partial fraction considered as minus 2 over 3 and x minus 1 and minus 1 over 3 and x plus 1. We must not forget the 3. I repeat. Just box this up, and this is our ready to be shipped. And yeah, don't forget the minus sign. Just don't forget the minus sign. See, like if I take minus common earlier, I had a chance of making mistakes, but I have a really low chances of making mistakes. Right? So moving on to example 3, the maximum power of the numerator is greater than the maximum power of the denominator. And I'll just make a column for long division. So I'll copy the denominator. I'll paste the denominator. I'll make the denominator small. And yeah, then copy the numerator. Then paste the numerator. And just make the numerator smaller yet again. I'll change the color of the man. This is annoying. And yeah, so I need x in the quotient, I guess. Just let me change the color. And yeah, so I have a x cube plus 7x square plus 6x. I'll subtract the whole thing, and plus turns minus. So I'll be left at minus 12x square and a plus x. Bring the minus 3 down, and I also need a minus 12 in the quotient. So minus 12x square minus 84x minus 72. Subtract the whole thing. The minus 12x squares cancel off. Minus turns plus, and I'll be left with 85x plus 69. And I can rewrite this as x square minus 12, that is the quotient. Changing colors just a bit. Wait, why the x cube there? My bad. Just change x cube to a x, whoever's watching. And 85x plus 69 over x square plus 6x plus 6, x square plus 7x plus 6. And this can be factorized. The denominator can be factorized, and this is the whole partial fraction we need to consider. So let's start by factorizing the denominator by breaking the numerator. So I have x square plus 7x minus, or just yes, x square. So plus 7x can be written as plus 6x plus x, and x taken out, x plus 6, 1 taken out, x plus 6. And the two factors turn out to be x plus 6 and x plus 1. So just rewrite everything down and write the denominator in factorized x plus 1 and x plus 6. Now, this is the partial fraction we need to consider. For now, just forget x minus 12, but don't forget to write that back down now in the final. So, 85x plus 69 over x plus 1 into x plus 6 is equals to a over x plus 1 plus b over x plus 6. And then cross multiply and cancel off the denominators in just one step. 85x plus 69 remains unchanged. Now use the cover up method, the second of the two methods, easier than comparing coefficients. Take x as minus 6. First of all, so a becomes 0, let's just say. And I have a minus 441 is equals to minus 5b. Minuses cancel off, and b turns out to be 44, 441 over. So when x is equals to minus 1, so b cancels off, or rather just becomes 0. I have minus 16 is equals to 5a, and a turns out to be minus 16 over 5. And then writing down, first of all, 441 over 5 x plus 1, and then it's a minus 16 over 5. Don't forget that a is minus 16, and thus b is 441 over 5, and this is what the partial fraction would look like after being solved. Don't forget the x minus 12. Don't forget the x minus 12, and write down the x minus 12 in your final answer. And this is your final answer. Box this up and leave it. That's it.